Hi, this video will demonstrate the usage of our automated smart contract hacking tool, as well as the flow and processes required to use it. So firstly, before we begin and use the tool, our tool is actually designed to work in conjunction with vulnerability scanner. So the example of a vulnerability scanner we'll be using today is actually Slither, which scans a solidity file of a smart contract to determine if there are any vulnerabilities within this smart contract. So in order to do the scanning, I've already copied over vulnerable solidity file over to the Docker container, which is this, and the Docker container contains the image of the Slither scanner itself. So before we begin, we have to select version of the solidity file we'll be using, which will be 0.6.6. And after we've selected that, we'll perform the scan of the file itself, which I've copied over into the user share folder of the container. After performing the scan, it is actually showing that there's a reentrancy in this function within the contract with the withdraw function. And now that we know that withdraw function is actually a vulnerable function, we'll move on to the application to show the generation of the smart contract as well as the full exploitation of this smart contract.
So we'll begin the demonstration of the single reentrancy function of the automated smart contract hacking. So what you're looking right now is actually a vulnerable smart contract that is vulnerable to the single reentrancy vulnerability. So it's hosted on the local blockchain Ganache, and the current value of the vulnerable smart contract is 50 Ether, as can be seen. So now we'll begin the attacking. We'll be running the app. The app will first ask for the attacker's wallet address. So in this case, you'll be using the second row as the attacker's account. Copy the wallet address as such, and the private key. So we're picking one for single reentrancy attack. So the app will actually require the user to actually give the path or the file of a .ebear or .so format. This will be used to actually construct a malicious smart contract. So in this case, we'll be using two, which is .so, as it provides it actually uses a more comprehensive algorithm to construct a malicious smart contract. But don't worry, as long as you know how to use the .so option, the .ebear will be a breeze. So we'll be entering the name of the exploit contract, which in this case you'll be naming it E12. Then it will also ask for the vulnerable function that is found in the vulnerable smart contract. So previously, when we have ran Slither, we were able to identify the vulnerable function from the vulnerable smart contract that is hosted, which is withdraw. Next, we'll be entering the vulnerable smart contract address, which can be easily found in Remix, copy as such. And, this to allow this actually to help in the construction of the malicious smart contract, and as well as to allow the malicious smart contract to interact with the vulnerable smart contract on the blockchain. Then you will ask for the location of .ebear file. The .ebear file can be found in the folder projects, in the projects folder, but to save time, I will actually copied it into a notepad. The API file would be actually the vulnerable smart contract API file, not the attacker's one. You also ask for the location of the vulnerable smart contract's source file, which also can be found in the project folder, but likewise, to save time, I already put it into it. Then it will start generating and deploying the malicious smart contract onto the local blockchain. So for this example, we're using the automatic attack. It will ask for deposit amount, so this is to actually allow the mapping of address to the vulnerable smart contract. Then it will begin attacking. So the malicious smart contract will continue to attack the vulnerable smart contract until there is 0 Ether left. Okay, it's a success. The vulnerable smart contract currently has 0 Ether, and you can see in the attackers, he is able to successfully steal 50 Ethers. This will be the demonstration of the manual hacking instead of the automated single reentrancy attack. So you'll be typing 2 instead of 1. So right now you give instructions on actually how to conduct the attack sequence in order to steal the Ether from the vulnerable smart contract. So you will actually essentially need to actually deposit Ether into the vulnerable contract, so as to allow the mapping of the attackers into the vulnerable smart contract. So let's first get the value stored in the vulnerable contract, which is 48, which can be seen in Ether also, in Remix, which is 48. Next, we need to follow the sequence, which is depositing. So let's say let's enter 5. Then you can see they update the amount. Now we can begin attacking. So after attack, we can see that the number of Ether actually stored in the vulnerable contract has decreased. So we're going to continue attacking until there's 0 left. Then we can finally exit. We can check in the end that we're able to steal almost 40 Ether into the hacker's account.
Cross-function vulnerability, where a function calls a vulnerable function within the smart contract. So there will be a function that will be abused and a function that is actually vulnerable. So like from the Slither scanner, we look at the code itself. Actually, we will realize that withdraw all is a function that will be calling a vulnerable function, withdraw portion. So withdraw all will be the abuse function, and withdraw portion will be the vulnerable function. So firstly, we enter our wallet address and our private key. We will select the cross-function reentrancy attack, and then we will use SOL to generate a more comprehensive malicious smart contract that will in turn exploit the target contract. And we'll enter the name of the vulnerable function, which is actually withdraw portion, and the abuse function, which will actually be withdraw all. Then we need to enter the vulnerable contract address found here, the location of the ABI file. Then we will enter the SOL file, and it will automatically generate the smart contract that will be used to exploit. Now it's deployed to the blockchain, we can proceed to do the automated reentrancy attack, which will just allow us to automate the entire process. So the contract now detects or has sent a request to check how much ether has been stored inside the smart contract, and there's actually 50 ether inside, and so the user or attacker will decide how much they want to deposit into the smart contract, as there is a mapping to the user's address. So now the application will automatically perform the exploit, and we will retrieve the ether, and now the entire contract has been emptied of ether and has been transferred to the attacker's Ethereum wallet. In the case where a user wants to perform a manual interaction with the vulnerable smart contract, they can choose to do so by selecting the second option, which is the manual interaction. So after they've selected it, it will give you an instruction that a deposit should be made first. So we can choose to get the stored value, we show there's 60 ether inside the smart contract. We can choose to next deposit something into the ether contract. As explained before, there is a mapping that is required. So now that my address is now mapped to a value inside the smart contract, I can choose to exploit, or I can choose to show the value now is equated to 70, and we exploit the vulnerable function inside the vulnerable. And we can check to see, yes, the exploit has succeeded. Some more to try to empty out the entire balance within the smart contract. Now that it's all empty, we can choose to exit, showing now that I have definitely gathered all the ether from that smart contract.
For passing the time to me, so I'm going to talk about the delegate core weakness attack right now. So as we take a look, before we move on, let's take a look at the wallet address that we're using, which is 917. If you look at here, 917 is this with a balance of 100 Ethereum. And yeah, so but before we really dive into the application to see what can it do, let's take a look at the contract that we'll be targeting, which is called bank. And of course, this is normal functionalities such as deposit, withdraw, and get balance. But then we realize something. They have this function called queue. What is the queue function? You may wonder. So basically, a queue function, what it does is it basically self-destruct the whole entire contract. So the contract will be gone, and whatever Ethereum that's inside will be passed to the owner. Another thing that shocks us is they have this fallback function. Basically, it's a function that is initiated and called if someone calls this contract function that doesn't exist inside of it, such as like perhaps function hello. And when the person calls that, you'll call this function. And we realize that this function, this fallback function, has a delegate call in it. So by using a delegate call, we know that they are linking the functionalities to another contract, which is of the address of this. And we continue research and we found out that the contract is over here, which is called live. And we see whether we can exploit about it. So we're looking at the functionalities of live. We realize that they have this function called pawn, which basically whoever calls this function will be named as the owner. And this is absolutely dangerous because using a delegate call is like a delegating another contract to run the functionalities for you. So basically whatever thing that change over here, that basically applies to the owner, when the owners change, the changes will apply over here, which means that the current owner of the bank will be the one that calls this function. So after knowing that there's such flaws, we take a look at the balance inside of this bank contract first, which is 210 Ethereum, and the owner of this bank is C231. Okay, with that knowledge, we proceed on with our attack. So delegate core weakness attack, yes. Does it requires our address? So if you take a look at the library, it just calls the function pawn. It doesn't need to have my address inside, so I will just click no. And does it have more than one function I would like to export? Yes, which is the queue function as well. So what's the name of the exploit contract I will name it? So I will name it as attack you. And what's the function name that I'm going to abuse, which is pawn. The additional name that I'm going to abuse, which is queue. And enter the vulnerability contract address, which is over here. So I copy that address right there, and I paste it, and I enter. So now currently it's generating the attack contract, and it's implementing into the smart contracts and into the blockchain and looking at attacking. So as you can see, I've claimed over 210, which is whatever Ethereum that's inside that current bank smart contract, and I withdraw it into my bank. So to double check that, let's take a look at here. Currently the get balance previously was 210 Ethereum, but now if I click it again, it becomes 0 because contract destroyed, and the owner will be 0 as well, and all the value right has been sent into my contract and withdraw into my bank. So just now as I mentioned, my one is called a 9171, that's my address, and the balance has risen by 210. So with that, I hope you understand that delegate call function is important, and if you do not know how to use it, do not use it, because it might cause your whole contract to be destroyed, or even worse, or your Ethereum to be lost. Thank you.